All right, recording is rolling. Welcome to Friday, August 18th. Ooh, and we are seventh period. We are 34 minutes from another weekend. So we're going to finish this Geneva Drive project. When you guys were walking in, you saw the animation that was playing yesterday. All right, so here's my model from a while back. I'll probably do today what I did yesterday, which is working out pretty good. I'll give you guys some time to work independently, and then I'll come up here every once in a while and add to this model. Here's where we got to yesterday. If you were keeping pace with me, maybe yours looks possibly a little bit like this. Okay. Give you guys some hints. Okay. You don't have to do exactly what I did. In fact, mine in the animation don't look exactly the same as each other's either. Okay. So remember some things I want you to get out of this project. One is use your imagination. You get to utilize your spatial skills, think in 3D. You guys get to get your hands on these objects. You guys get to look at some complex system and break it down into fundamental parts and build it up from there. You guys get to communicate with each other and give each other tidbits and thoughts. So yeah, so lots of good skills going into this one. Right. Oh, this solar energy challenge. I'll give you guys a few more days on this, but I'll probably throw the solution up here on Monday, I'm thinking. Right. So if you want to get challenged. Next week, I want to start with trigonometry and vector components I'm trying to get to. And then by the end of next week, start on linear motion. There have been quite a few schedule changes, but those are settling down by about now. So if you're just switching into this class, then hey, you haven't you're not super far behind. You can catch all the videos that we've done so far, but you're gonna be all right. Name forms. I know I've mentioned these a few times. Oops, that's not the name forms there. Let me find the right here. All right, this name form. If you are going by any name that's not your legal name, so the new law is, where is it? Specify any use, the use of any deviation from a child's legal name in school. So yeah, if that applies to you, then please do take it home, get it signed. I would appreciate that. So I don't get into troubles. Administration is requesting no hall passes, no restroom passes the first 10 minutes and the last 10 minutes of class, I think to help maintain order a little bit more around the school too. So if you do need a hall pass, restroom pass, let's try to stick this. So please just ask like somewhere in the middle half-hour class. All right. Yeah, so here's what we do. I'm gonna switch over to this animation and give you guys a few minutes to just work independently and then do what I did yesterday. Every once in a while, hop in and give you guys some hints. All right, so with that, let me go ahead and pause this recording. All right, and recording is resumed. All right, so I've been walking around class, checking out you guys' projects. You guys are making some good progress here. And so project's looking pretty good. And so here's how far I got yesterday myself. Now, again, if you're off on your own beaten path, that might actually be a good thing, right? If you're using your imagination, but if you wanted to steal some ideas from me, then here's what we got so far. A couple of circles. I cut some teeth in one of them, right, for a cogwheel. Now, remind you guys, when you make your cogwheel, you guys see how all my teeth are evenly spaced? Ooh, I went with 17 for this class. 360 degrees divided by 7. I think it's like 51.7 degrees from tooth to tooth. Okay? But it's really important that you have radial symmetry for your teeth. Why? Well, let's look back at this model. It has 8 teeth on it. Remember, as one peg is leaving this gap, the next gap is already aligned to accept the next peg. And that only works all the way around as long as all your teeth are evenly spaced. Okay? So that's an important property of this cogwheel. So you have some radial symmetry going on. You might have 7 teeth like mine. You might have 6 or 8 or however. Okay. I had cut a bunch of similar sized rectangles and started wrapping those into cylinders. And I made a couple of axle systems by the end of yesterday. Right? So like this little spin here, I got a smaller diameter cylinder inside a large diameter cylinder. Right? And same thing over here. Oh, while I'm at it, remind you guys too, I did make these different size cylinders, like different heights, right? One has short feet, which leaves a lot of cylinder behind for a tall cylinder. The other one I cut long feet, which leaves behind a short cylinder. Now, that's so that when I pop these underneath these cogwheels, there's going to be a height differential. which I want a little bit of a height differential because see how like on the model I have the cogwheel sits a little bit taller than the peg wheel, so the pegs can come up from underneath, right? So thinking 3 dimensions, right? A lot of little things to keep track of here. Right? Let me go ahead at this point and go ahead and roll a few more cylinders. I need a handle for the peg wheel and also some pegs. Now, if you only put one peg on, it should technically work, but it might get lopsided. I mean, these are kind of a paper type materials in this Florida humidity. If you throw in at least one more peg, maybe it could balance it. Right? I have 3 pegs on the outside. You guys see how the center of mass of my peg wheel like is at the axle center? Right? So that could just be one of those engineering tidbits. Makes work a little better. So pop off one of these rectangles, wrap this up. If you have a pencil at your desk, that could be a good trick is to just wrap these rectangles around the pencil to make cylinders that way. They'll be uniform size. You can just slip it off the pencil. I have pens, so a little harder for me, but I could wrap mine around the cartridge. You can pull the cartridge out. They very easily slip it off that way. Let's see, press and hold that. Throw a weight on top of that. Hold that in place for a little bit. It's right here.
Any advice? What do I do? I'm lost. My fault. I wanted. I thought I had it. Oh, see it's working. See it's working. I didn't yeah.
But that's
I
chill motivation. Oh my God.
wait, what? Like,
All right, so just rolled some cylinders for the peg wheel, pegs in the handle. Press and hold that. I'm gonna throw some weights on them. You guys might have some weight tight objects around your desk you can use like that too, possibly. Maybe help. Use the pencil method. You can press and hold it. Works pretty good. All right, so let me go back and I'm gonna switch my screen back over to this animation, and then pause this video and walk around and check out how you guys are doing. All right, recording is resumed. Yeah, so walk around the classroom. You guys are doing a good job on these. You guys are making good progress. Projects look good. A lot of you guys are really close, really close. All right, so let's see, my cylinders are probably dried for sure by about now. Yeah, I think it's feel pretty good. All right. Okay. So next thing, remember I want to take these cylinders and these are going to become, say, a handle and 3 pegs on the pegged wheel is what I'm looking at. Hey guys, do I want to take this cylinder as it is right here? And it's pretty well cylinder shaped. And just go ahead and glue that directly on there? Yes or no? You guys are correct. The answer is no. Because that's what, is that a surface to surface connection or an edge to surface connection? Yeah, that would be like edge to surface. I know it's like a cylinder shape, but it's still like a circle edge. So if you glue it like that, like takes a long time to dry. Versus if I can have some kind of surface to surface, ooh, that'll dry a lot faster and a lot better. What was the solution to that I was showing you guys yesterday? Yeah, cut feet. Right. Now some other students I saw came up with the other solutions too. Like they cut other strips of paper and just glue those separately, which is similar type of solution that'll work too. So If you can think of your own creative way of doing this, then go for it. Try stuff out. This is something I found works, so let's go ahead and do that. Let's open.
I don't know about it. Yep, like, I don't know, like, I tried playing the drum once and like, and I just can't do it, like, my feet can't do it. Yeah, exactly. Oh, yeah. Anyway, Sean, how was your drum set?
Good.
Yeah. All right, everything again.
Okay.
Oh, but before I start gluing these pegs on, one detail I almost forgot. Right. So go back to my own model here. Do you guys see how? Okay, so I have 3 pegs and a handle. This peg wheel right here. Do you guys see how its center of mass is like at the point of the axle? So they can only put 1 peg on, and the center mass would be like, well, it would be like lopsided. But I have it symmetrically balanced so that the center mass is like right at the axis. But the only way to get it like that is you have to have an equal angle from peg to peg. So who could tell me, here, students have been, this has been a good challenge question all day today. Who could tell me how many degrees from this peg to this peg? How many degrees is that? 360 divided by 3, which is 120, 120, winner, bing, 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 winner. That's 120 degrees, 120, 120. Right? Multiples of 30 degrees, you'll see quite a bit in this class. It's really nice for a lot of sine and cosine reasons. Yes, I want to measure this out. You guys have protractors on your desk. Let's get a little bit of protractor practice. I'll throw down a random mark just where one of those pegs could go. Right, I'm going to take this node of this protractor. I'm going to put it right at the center of the circle. I'm going to zero out that first mark that I made. Then sweep out 120 degrees. Put a mark right there. Rotate the protractor, zero out that mark. I still got the node of the protractor centered on the circle, zero to that mark, sweep out 120 degrees right there. And then finally, let me do a final check, make sure it wraps back around. So if I zero out that last mark, let's sweep, 120 degrees. That sounds like 121, but close enough. All right, there we go. So now I know where to place these pegs. I think this peg's a little bit bigger than the others, so let me treat that as the handle. How about that? Try to orient this so it's orthogonal to that surface. Ish.
I know, it's like that. I think my favorite is all the
And then there's
Wait, Zachary.
Yeah,
I'm taking Sunderland after.
Oh, really?
Yeah. Either Emily or like.
Yeah. Most of them. Yeah, you're follow up. Yeah.
So, like, yeah, for me,
No, are you
like,
gonna
like after high school.
Probably didn't even.
Finance. Oh. Yeah. You're amazing. Like, I'm also interested in like nutrition. Yeah. Okay. Okay. No, like I didn't want to.
All right. I think I'm just going to go ahead and take my to completion right now. So I got my two gears, one with teeth, one with pegs and handle. Okay. I got these couple of axle systems. I just have to glue this in place. Now remember, my two axles, one's a little bit tall with short feet, and one I cut longer feet so that it rides a little bit shorter. Okay? So it gives it a height differential, right? So that the peg wheel can come up underneath the tooth wheel. Okay? So see the long axle, I went over here attached to this tooth wheel. Let me mark the center so I know exactly what I'm looking at here. Center, center. All right, here we go. Go to there.
I don't know. Kind of big, but I like molding. No, I don't know, like, it always takes me.
Okay. Gotta sit down.
Yeah.
I mean, that's fun. Oh.
Yeah.
Yeah, so today's the last day to work on this. Yep. Today's the last day. All right, I'm gonna leave that there to dry for a moment and yeah, take a quick trip around the room and see how you guys are doing here. All right, recording is resumed. All right, so took a quick trip around the room. A bunch of you guys are real close. You're like right at the last step. You guys are just, some of you guys are just waiting for parts to dry. All right, so yeah, now I'll go ahead and assemble the rest of this. All right, so there's one last consideration I have to have. The only thing I haven't glued in place is the base axle to the peg wheel, but everything else should be in place if it dried. Right? Right, so this will be fixed in place. Ooh, yeah, that looks like it's going to spin pretty good right there. Right? Right. So there's one last consideration I have to make, which is that I have to get the correct center to center distance, like the axle to axle distance between these two wheels. It's like if I have them too far away, then it's not going to, this peg is not going to catch that tooth at all. But if I have it too close, then maybe it'll catch it, but then it'll get stuck right there. So maybe there's like an optimal spacing right about there. And then as this peg leaves this gap, the next gap is lined up to accept the next peg. That's right about where I want that, like right there. Right? And you might have to go back and cut the gaps a little bit deeper. Like mine looks like just the right size where it'll just work. So let me get that marking right there. All right, so that's exactly where I want to glue the base of this axle. All right, I'm going in for the finish here. Well, this might take a hot minute to dry, but besides that, should finish this off. All right. This will rotate right in there. Pop this back in place. All right, there we go. I'll spin just like that. Press that down.
No.
Ah, I think that will work. All right. Yeah, when that dries, oh, look at that go. Look at it go. Oh, yeah. Yeah. Dang. Oh, these folds are getting caught a little bit. It's working pretty good. Yeah, this feels like it turns pretty good too. Maybe I'll slide this a little bit further away. There we go. There we go. Yeah. All right, that's one of the better ones to make today. Some of these work better than others, but yeah, the 7-pointer star right here, that is working. Just gotta leave that to dry. All right, so I'm gonna take another trip around. I know I've got some winners by now. I'm gonna see who's a winner here. Since we have 5 minutes of class left, I see everybody's done really good job on these. You guys are working hard. You guys doing a good job. I know some of you guys had like 10 minutes you could get to the end, whereas we only have about 5 minutes left here. So I'll give you guys all points in the book. This is a first assignment in this class. We'll start on the trigonometry on Monday. Guys, one of 3 things you can do with these. If you want to take your project home, you can take it home. Share your siblings and your parents. They'll be super impressed. You guys are mechanical engineers now. You are certified. If you want to throw it away, you can throw it away. If you want to leave it back on the lab table, that's okay too. I'll probably eventually be cleaning the lab area. Right? But yeah, we are just a few minutes from a weekend, and I will end the recording right there. So good job.